how Linux boots. It's easy to know. Many of us read the source and explained every bit of it, similar for BSD variants, Minix, and Plan 9. It's not about Linux, Windows, or Mac, rather, how computer boots. Let's take a ride using Phasm. Phasm G. It's like Guruji for this project. I will explain why I choose Phasm Z over NASM or even GAS. I will explain why I dropped traditional assemblers like NASM, Phasm 1, or even GAS for this matter. And the UEFI, that means the Universal EFI system that is responsible for the boot sequence. And why Apple A7 was a revolutionary. What are the executable formats like EXE, ELF64, COF, even Mac O, that means the Apple's Mac OS object and executable formats. Before that, let's start programming and build the binary first. What do we need? We need the phasmg binary. For that matter, I already have installed the phasmg. Which phasmg? As I see, I already have this binary. That means whatever assembly language I write over here, I can build that by using phasmg. Along with that, I need some extra include files. Those are located over here. Let me decrease those files and let's take a look at some examples. As I see, still 8086 and x86. Those are some examples. Let's write our first code. mkdir So let's go to the boot folder. Yes, pwd. I am right now at this folder. Let's create the boot assembly file using micro editor asm. It is not C, so I cannot type hash include. Rather, I will simply include format/format.inc. What I need next, I need the basic definition of UEFI. So I will grab a basic definition from the internet and paste it over include uefi.inc. What next I need? I need to include utf8.inc. Why? That is because just having ASCII characters is not enough. Nowadays, we need UEFI. Remember, I already spoke about Plan 9, the operating system. The same people created C, same people created Unix. Those same common people created the Plan 9. That is a great operating system. But we will stick over here. By the way, why Plan 9 still relevant over here? That is because we need the UTF implementation, and the first UTF implementation was done by Plan 9. So let's include UTF-8. I think those three include would be sufficient. That is because I don't want to create a mess right now. Let's simply focus on the bare minimum. Let's define the format. Format PE64 DLL EFI. Is there something fishy? Yes, you must be wondering like why the hell this DLL for? As I understand, DLL is a Windows thing, and if you know PE, the PE format is also from Windows, dated back to the QDOS and all those dirty things. So PE64 version, why I am including this PE64 rather than including something more modern like ELF64? Why not ELF or even ELF64? Why is PE64? Do I love Windows over Linux or even Mac 64? No, I'm not into any kind of relationship, but it is needed. I will explain why it is needed. Let's define the entry point. EFI main rather than section, code, executable, readable. Let's define the EFI main function. I cannot use curly braces. I'm missing C. SUB. Please fast forward this section so that the programming of this file do not consume a lot of time. You can fast forward this one. System table RDX. Let's save it. Wait. Now I have the assembly. Let's get those utf.inc and it's better utf8. I got the inc. Let's comment it out. 7 quit. Now micro efi.inc. Let's paste it. 134 lines of code, included code. Let's quit. What do we have? We have the boot in assembly, EFI, that is the include file, and UTF-8 include file. What we don't have? We don't have the format. As you see, the format file, even the folder I don't have. That is because it will take from here, include. Why this file? Because I will implement some extra thing over the time. So I will include that one later on. Okay, let's quit and give it a try if it runs on the first time. So it will include the whole thing from here. Then the phasmg binary will build the boot.efi. It is the time to check whether it works. Let's Yes, flat assembler. G means global or guru level, or whatever the thing is. 3 process and 153 bytes. There is a limit that how long the boot sector can be, and the limit is very less. Let's test with lsla. As I see, there is a file called efi.inc. Can this file boot? The boot.efi is 1.5 kilobyte. Can it boot? How can I boot this? I can put this into a pen drive and test it out on the real hardware, but that will be done in next day. But what I can do really quick, I can do by using QEMU system 64. As I see, I already ran this type of 64 QEMU related system commands. So the command is QEMU system x86 underscore 64. That means this QEMU system can emulate 32-bit along with the 64-bit instruction set from the Intel and AMD. What next? BIOS is OVMF. What does it mean? It means Open Virtual Machine format, something like that. I am okay with that. What next? Net none HDA FAT RW ESP. What next? Nothing next. That means I need another terminal. Let's open another terminal. It is so big. Let's clear the screen. CD into boot the project, and let's create a ESP folder. Within that folder I will create EFI, then boot. So mkdir-p. What next? ESP slash EFI slash boot. The directory is created. Now copy this newly generated or newly created EFI file, cp boot.efi into ESP EFI boot, and I want to name it as boot64 I'm not sure why it needs in capital, although the file is ready. HDA, that means it will use as a hard drive, as ATA hard drive, and it will use ESP mode read, right? Let's wait. Yep. No bootable option or device was found. That means I missed something. Press any key to enter the boot manager menu. It will open the boot manager UEFI QEMU hard disk. That means there is nothing. Yep, I see there is always a catch. I'm not sure why. I even miss some small details. If you see ESP EFI boot, this file should have this file name. By the way, don't stuck over here. Go all the way TX and 64 EFI. Then your program will start. And this time I will just ignore no graphics. I'm not sure how to quit from no graphics. That is the reason why I will omit no graphics, and it will use the ESP folder to boot from. Okay, I will have to go to the project folder again. Now I think it will start. Yes, the QEMU has successfully booted. That means it is expected that if I create a partition, that means bootable partition, and I put that EFI file over there having 1.5 kilobyte, this will boot. As you see, it is successfully booted. Next, we can continue working on that and hopefully make a great operating system out of it, like GoPOS Linux can be a great form, having GoPOS core or something like that, or even we can create and implement our own instruction set. Do you understand? Like we can create our own instruction set. Previously, if you go back all the way when the H64 or even H65 encoders were using software encoders, nowadays each and every hardwares get their own dedicated media converter, encoder, decoder, each and everything hardware implemented. That means all those things will not consume your CPU cycles. So your CPU, overall your processor, overall your system will be much more lighter. Like nowadays Mac M series, M1, M2, M3, M4, I'm not sure how many M will be there, but each and every M series have their own dedicated graphics rendering coprocessor that can handle encoding and decoding things, so that video encoding, video editing, even working with so-called today's AI is much faster. So if you want to create your own operating system, your own bootloader, your own instruction set, your own CPU instruction set, even your own computer company or anything, you must use and implement these type of things. Even you are not having that kind of intention, it's better to know those type of things. It will help you understand the system, like what the computer system works. I'm not sure how to define a computer. Even like, does our day-to-day mobile can be called as computer? I'm not sure, but as I see today it is working. I will continue tomorrow and we see. Hello EFI world.